Good afternoon, everybody. I'm going to talk today about our Sporenado spore trapping project. So along the same vein as some of the other talks today, it sort of fits in with that disease, crop disease, and fungicide application piece. So has anybody seen one of these before? George has seen lots of them. Yeah, I bet he has. Anybody else? Mike has seen them. Aaron has seen them. What is this? A wind vane. Yeah. This is a Sporenado spore trapping device. So it's a passive unit that collects spores in a field. So it's something that we're doing some research on, some field research on this year to see if we can build it into a piece of an integrated fungicide application decision support system, I guess. So, but before I get into the spore trap itself and kind of the ins and outs of that and how it sort of fits into helping us make better decisions, we sort of have to take a few steps back and think about crop disease in general. Now, I think you've probably had a lot of information on that already between the mics. So I caught Mike Gretzinger's talk this morning. I only caught half of Mike Harding's this afternoon. So if I'm overlapping anything, just speak up and I'll fast forward a little bit. So crop disease in general, the basics of it is the disease triangle. So who can tell me something about the disease triangle? Host. There's three sides to the disease triangle. 3 sides or 3 corners, however you want to look at it. There's the host, pathogen, and environment. So what's involved in the host? What's the host? Yeah, the crop. The host is the crop. The host is the crop that's susceptible, that could be infected. What's the pathogen? Yeah, the pathogen is the disease. And the environment? Yeah, the weather, kind of what's going on. So those are the three elements that need to be in place for disease to develop in a crop. So the host, a susceptible host, a pathogen, and an environment that is conducive to establishment of that disease. So this will probably be a little bit of review from some of the talks earlier, but what are some of the things we can do to mitigate our risk of disease developing? So what can we do on the host side of things? What are some things we can manipulate with the host that sort of lower our risk of developing disease?
Genetic resistance.
Yeah, resistance. So there are different varieties that might have different levels of resistance to different pathogens. What else? Yeah, different host, right? So we've talked. This whole study here is a rotational study, and that's a big one, right? So for this spore trapping study, we're focusing on both Sclerotinia and Fusarium head blight because those are the tests that are available right now. So for those diseases, Fusarium is a cereal disease, and Sclerotinia affects broadleaf plants. So by alternating those, by switching between, we grow plants where that pathogen can't infect it. So we have a host that is not susceptible to the pathogen. Anything else on the host side? Does the susceptibility change throughout the season? So yeah, so stage would be another one. So there are stages at which the crop is going to be more susceptible to being caught by disease. And what about on the pathogen side? What things can we kind of do to manage the pathogen? That's that rotational piece as well, right? So if we're growing crops in a field where there's history of a certain disease, there's going to be more likelihood for that pathogen to be present in that field. But there's not a whole lot more we can do to manipulate the pathogen piece. There's maybe some seed treatments, having the proper seed, clean seed, etc. And what about the environment? This is probably the element that we can probably do the most to manipulate. What can we impact on the environment to mitigate our risk? Yeah, water's a big one, right? So dry land or irrigation, or perhaps even timing of irrigation. Anything else?
Biodome.
A biodome?
Fungicide?
Fungicide, yeah. That fits in there somewhere. I don't know if that's pathogen or environment, but yeah, fungicide is definitely one of our big tools. What about seeding rates? So denser seeding rates and earlier canopy closure kind of creates that warm, wet environment. So the biggest thing with the environment is heat and moisture. That's really conducive to establishment of disease. So thinking about both Sclerotinia and Fusarium, again, those are the diseases that we're working with this trial. You know, what are some of the things with the host, the pathogen, and environment that sort of fit into the picture here? Quiet audience today. Let's go a different direction. What are the effects of Sclerotinia? What can Sclerotinia do to our crops? How much yield loss? Yeah, 20 to 50%. That's probably about right. It can be pretty severe for sure. And what about Fusarium? Yeah, that's right. Yeah, there's potential for yield loss, but it's definitely the quality side of things, where we lose quality, where the grains that are developed are no longer suitable for consumption by humans or livestock after a certain threshold, and that can have pretty significant economic ramifications. So we've got a couple of diseases that can really affect our yield, that can really affect the bottom line. And we don't really, we've got a lot of control measures that we can implement early in the season. So at seeding time, we can kind of manage our risk with seeding rates, with choosing varieties and cultivars that are resistant. We can manage irrigation, but once we kind of get into the time of the season where our crops are the most susceptible, and when is it? When are the crops most susceptible to disease? Yeah, flowering. Yeah, that's it. So once we get to that point, we don't really have a lot of options for for control. Things are sort of set in stone. And if we think about the host, the pathogen, and the environment, these are the things that we're thinking about when we try to quantify our risk level and decide whether or not we need to apply a fungicide. So on the environment side, we know that our risk changes depending on how much moisture we've had. So if it's been really wet for 10 days or so, if it's been warm, that's conducive to development of disease. So that's one of the points on the triangle where you think, okay, we probably should be considering doing a fungicide application. The host, again, this you're thinking about what's the crop? Is it susceptible? Is it at that stage, right? That stage where it's more likely to develop disease. And then the pathogen is what we know the least about. So it's really hard to understand in season, what the pathogen is and what the risk is associated with it. We often use what's our cropping history, has there been a history of disease in this field. So for both of these diseases, they're often on plant residues. So they'll stay in the field. And I think Mike had talked a little bit about some of the options as far as tillage and rotation, but they do live in the fields. They can live in there for a few years. But that's as much as we often know about whether the pathogen is there. So that's where a tool like this comes in, and it can tell us whether or not there are spores for this disease in the air at the time of risk, sort of in that spray application window. So it's a piece that can help us better understand and evaluate our risk for disease establishment and maybe make a decision on fungicide application. So spore traps aren't exactly a new technology. It's certainly not really recent, but this is sort of a much simpler iteration of it. So over the last 10 years, maybe more, there's been volumetric spore traps, and how they work is they've got a vacuum on it. So they'll suction through a prescribed or measured volume of air and measure how many spores they collect there. And so they collect all the spores, then somebody has to plate it and examine it and determine what spores there are. And so it's a cumbersome process, and there's a risk of misidentification of the spores that are present. Whereas this uses a DNA test, so a PCR test, and it can tell within 24 hours, a 24-hour turnaround test, identify whether the spores for Fusarium or Sclerotinia are present or not. So it's a tool that's pretty easy to use. It's a quick turnaround, and it gives us that sort of close to real-time information that might help us make better decisions on spraying. The volumetric spore traps, those cost in the range of $10,000 to $20,000. So it's a pretty cost-prohibitive thing. It's probably more of a research tool. It's not really a practical tool that farmers could take advantage in season. But this unit here, I mean, it's a pretty simple unit. There's not a whole lot to it. So This piece here, this is about, I think about $300 for the trap itself. We built a little stand for it, and it just screws on. And then there are cassettes that are inserted into it. So I do have one here. So this cassette gets inserted into it. I don't know if you want to zoom in on that. So it has just a little membrane in it. If you want to come and take a look, it just has a little membrane in it, and that catches all the spores. So we place it in the trap for a week or so, 4 days to a week, and then we collect it after that time. We send it off, and 24 hours later, we know whether or not spores are in the air. So that tells us, is there a risk for disease development or not. So as far as use, I've got a couple of blanks here. I didn't want to contaminate that cassette, but pretty easy, pretty simple. So there's a slot in there, and it just snaps right in, and that's it. So it sits in the field for a week, and then it just snaps right out, or it should. Pretty simple. So then we just take this, we mail this off to the lab, and 24 hours later we've got a test result. So as far as ease of use, and then the DNA test is more reliable than a microscopic test. It is or it isn't there. So that's kind of nice. The disadvantage is that it's a qualitative test. So whereas the volumetric traps can tell you the number of spores per volume of air, so you sort of get how much the density or the number of spores. This is just, it's a positive or a negative, or it's trace levels detected. So there's enough there, but not enough to worry about, I guess. So that's, I guess, a disadvantage of it. But it's a really nice, easy tool. In fact, using it this year, probably the toughest part logistically is the shipping. Like that's the weakest link in the chain. So the shipping companies, they only run Monday to Friday. So if you don't get it there by Thursday night and you send it Friday, then the lab doesn't get it till Monday, and the lab runs all week long. But that shipping piece, so that, I guess, just a little logistical thing to consider is testing or collecting the traps on a Wednesday if you want that timely information. So the test is about $200, and then the cassettes are, I think, $20 or $30. So say you did 4 tests, you bought a Spore trap, 4 tests, 4 cassettes, you're probably looking at a little over $1,000 for the year. But when you contrast that to the amount that you spend on fungicide, I think there's real opportunity to invest in making better decisions for sure. So I don't know, any questions or comments so far before I move on? So one of the things that's really tough in making a spray decision, a fungicide application decision, is the limited information available. We talked about, we know a lot about the host, we know a lot about the environment, if the conditions are there, but we don't know a lot about the pathogen, and there's not a lot we can do to scout. So for Sclerotinia, for example, ostensibly you could get in there, you could look for the apothecia under the canopy, and that might give you an idea whether or not you might have the pathogen present. But it's labor prohibitive. I mean, that's a lot of work, and it doesn't even tell you whether or not those spores are going to be there, especially at that proper timing. So if these are placed at the proper time, we know yes or no that those spores are present. So if there's no spores present, the risk of disease establishing is pretty low. So some of the things that we wanted to look at, turning this into a decision support tool, is how best to use it. One of those pieces is the mail side of things, but also where to locate it in the field. So these spores, they don't tend to travel a whole lot in the field. 10 meters, 20 meters, probably less in most cases. I think there's examples of some outliers moving a couple kilometers, but that's really, really, really low probability. So this isn't something where something's going to blow in from 8 miles away. It's sort of what's in the field. So placement, especially with low transport distances, is pretty important. So we have 6 fields that we're working in. 2 canola fields, 2 dry bean fields, and 2 wheat fields. And we've placed a trap on the field edge. We've placed in what we've deemed to be a low risk area and a higher risk area. So those higher risk areas is an area that might have a history of disease, that has more moisture, probably denser plant growth, more canopy cover, and probably more pathogen there because of that past history. And a low risk area would be maybe a hilltop where it's a little drier, the crop's not as thick, and then the field edge, yeah, just the field edge, I guess. And there's other pieces in play. You know, as we're going through it, we're thinking about the effect of the wind on it. If we have a windier week, do we have a lot more volume of air going through? Does that throw off the results of the test? I mean, the test, it's binary. There either is or isn't. But there's a threshold at which it's detectable. So, you know, with more wind, maybe it kind of makes it seem like there's more there than there is, kind of thing. Also, variations in wind at these different locations. You know, at the field edge or in a low spot, well, certainly on a hill in a low spot, there's a lot of difference in wind. So the transport might change a little bit. So we're kind of looking at that. And so far, we've got 3 weeks worth of results back so far. So we've been changing these out since the middle of June every week. And the first 2 weeks, generally, the same result for all 3 locations in the field. So that kind of tells us that perhaps, I mean, this is early results, but perhaps the location isn't really a critical piece. It's more important just to kind of to be there. Last week we had a couple of results, a couple of tests, a couple of cassettes that we were not able to test. And that was because they were contaminated with dirt and mud, and half of those were on the field edge. So maybe southern Alberta, where we've got a lot of wind and dust picking up, there's sort of that risk of getting contaminated. So that might be something where you know, the edge of the field is maybe not the best option for it. So I don't know, any comments or questions so far? Yeah. Yeah, not as I understand, no. I think, oh, sorry. Does rain or moisture affect the test? And not as far as I understand. I think there's a risk if it does get moist and then it's more prone to collecting that dust. I think that'd be but just the rain itself, I don't think so. It's pretty well sheltered in here, depending on the rain event. But we haven't had any issues with it. And the locations that we're doing the research on, they're all irrigated, which amplifies the risk of developing disease. But we haven't had trouble with the tests on the water side of things. So, any other questions or yeah? Yeah. Oh, so okay. So the cassettes, the cassettes can be used for any disease. So it's the same cassette. When you send it in, you let them know what the crop is and what you'd like to test for, and then you'll get that test back. So this is something where, you know, so Fusarium and Sclerotinia, we often, you know, the field history is a really big factor in it, and they may not be the best diseases for something like this. They've had a lot of success with late blight in potatoes using these tools, and that's something that when it comes on, it's pretty explosive. It can kind of sweep in and make a big difference. So it's been a really good tool for that, and even if it doesn't tell you whether or not to spray, it can be a signal to do some scouting as well. So, and that's maybe leaf rust would be another one where depending on the year, depending on the weather patterns, that can really sweep in. And in fact, they were hoping to have a leaf rust test ready for this year, but due to some transport stuff and COVID, of course, made it tough for them to get the samples they needed to develop the test, but they're hoping to have that ready for next year. So that might be something that might be a really, really nice tool.
When you send it to the lab,
yeah.
you ask them to test for more than one disease, or is it only?
Yeah, just the one disease. Yeah, one disease per cassette. No, my understanding is just one. Yeah. So you send it in and you get it test for what you want. But I think you possibly could. I'm not sure though. Yeah.
How do you adjust? I know you've made it so you can adjust the height, but what are you targeting when you do
Yeah.
that? What's the purpose?
So this the unit itself. That's a good question. So there's a few pieces with the placement of it, like not only where in the field to put it, but the height. So we've set this up so we can adjust the height, and the idea is that this cup is just above the crop canopy. So 6 inches to a foot above the crop canopy, because of course if it gets buried under there, it's not going to collect the spores quite as well.
Do you plan to correlate the presence of pathogens in the cassettes with disease onset and actual disease ratings in the plot?
So the question is, do you plan to correlate the presence of spores with actual disease in the field? Yeah, so that's part of our study. So what we've done is we've left checks in every field that have been unsprayed by herbicides. So again, thinking about that disease triangle, just because the pathogen is present, it doesn't mean that there's going to be disease developing, because we have to have a susceptible host, so it has to be present at the same time when that crop is in most cases flowering, and we also have to have environmental conditions conducive to it. So that's a really good question. So just because we get a positive test, that's not necessarily a signal for a herbicide application. But we have weather stations in our fields as well, so we're monitoring the relative humidity, the temperature, and the precipitation as well. So we do have a good handle on that. So yeah, we will be correlating that temperature information to our test results and to disease observations that we're collecting weekly as well in the fields, in our check areas. And again, one of the challenges with, one of the limitations, I should say, with this tool is that it's a binary test. So it's either positive or negative, essentially. So it doesn't give us a quantity. So we can't say, the spore load is high or low. It's either there or it's not. So it's not the be-all and end-all that way. But if we know it's present, it's again that one corner of that disease triangle. So it means there's potential risk for disease developing.
The test results from the lab, do they come back with any recommendations, i.e. may think about spraying, nothing to worry about?
Okay, so the question is, do the test results come back with any recommendations on spraying? And no, they don't. They send the test results, and they also add some weather information from sort of the nearest weather station, which may or may not be kind of close. I think a lot of farms have their own weather data being collected anyways. So you'd probably want something that's a little bit closer to your field, especially when we're thinking about irrigation. So no recommendation, just whether it's detected or not. And as a decision support tool, I think you're thinking about, again, what are those other factors? And if there is pathogen, if it's warm, if it's wet, and I've got, a crop a field that I've got a history of disease, this is going to be another piece that says, hey, either we better scout or we better spray if you're on the fence. Other questions or comments? So it does sort of, this whole project does fit into, and I think Ken touched on this in his presentation earlier, but the value of fungicides to begin with. So for disease like Sclerotinia, the fungicide is only so effective. It's not always effective. I don't know if Mike would have a comment on how effective fungicide applications would be.
Yeah, depending on whether the timing is good and the conditions are good and the nozzles are right. I mean, there's all those factors that go into it.
Mm-hmm.
But for things like fusarium head blight, where our fungicides are registered for suppression only, that's tough.
Yeah.
And for Sclerotinia, where it's really hard to hit the target.
Yeah.
And hit it at the right time, it's challenging. So a lot of fungicide applications don't solve the problem.
Yeah.
Especially with those two diseases.
Yeah. So I guess to sort of summarize Mike's answer, there's a lot of factors in play as far as being able to hit the target spot, be able to do things at the right time. We've talked about some water volume, especially Sclerotinia. That target is down low. For fusarium, we've got vertical wheat heads that can be tough to get that good coverage. So there's a lot of mitigating factors that make it tough to do a really good job of fungicide application. Yet in the industry, we do tend to do prophylactic, preventative applications. It's sort of part of the management practice. It's a risk mitigation tool. And our idea with these spore traps is maybe that's another piece of, this is the piece of information in that, again, that disease triangle that we know the least about, certainly in season. And if that helps us to make a better decision on whether or not to apply a fungicide that may or may not be effective, spray windows can be really tough to hit, especially here in southern Alberta when we get a lot of wind at times. So yeah, I mean, I think it's worth evaluating, the efficacy of this practice, and this is a really good tool to help us do that, to do a better job. Where I'm at for time, do I have to go off my notes? Go rogue?
Yeah, we've got lots of time.
I do have lots of time. Okay. Yeah, I don't know. I feel like Mike and Mike kind of covered most of the disease stuff. So, like, how much time? What were we at? Give me a number. 2:25. Oh yeah, I'm almost done. I don't know. Any questions? Otherwise, I don't think I have a whole lot more.
What's our end game for this study? Like, is it 3 years down the road we're hoping to just be able to say whether or not this works?
Yeah, so the goal with the project is to be able to, to know whether or not this works as a decision support tool. So again, we have those check areas in the field that we're going to be evaluating. So do the test results have any correlation to development of disease in untreated areas of the field? Do they actually, correlate to the risk and to what actually happens? Can we draw a connection there? And that'll tell us, is this a tool? Can this be used as a tool? How often do we have to change them? So we've been doing weekly, changing them weekly, but maybe a little more frequently at some more appropriate timing. So sort of those heavy risk areas when we're just getting into so just at head emergence in fusarium, that's sort of that where that spray window comes into play. So is timing a factor? Can we detect differences? Can we see that the spore load is higher at certain times than other times, and does that correlate to those risk timings? So we're collecting staging information as well. So it's all those pieces that come together. And again, the location one is a big one. So at the end of the study, we'd like to be able to say, hey, this is or isn't a useful tool, and if it is a useful tool, this is how to use it, this is where to put it, this is how often to change it, all these kind of pieces like that. So yeah, I think there really is a lot of potential. It's a really relatively cheap and easy way to get a piece of information that we really don't have a lot of in season. So. I mean, I for one am kind of excited about the opportunity here for sure. So,
are you looking at, let's say you get X amount of information from having one in the field. How much better is the information if you have 2,
yeah.
or 3, or 5?
Yeah.
Are you looking at that too?
Yeah. So Mike asked if we're looking at whether or not we get better information by having multiple locations within a field, and that's. Yes and no, I guess. So again, we've got the 3 locations in the field, so a high risk area, a low risk area, and it'll be interesting to see whether we get different results in those different areas. So if our tests, because the spores do move around, not a whole lot necessarily, but if we do get different results in different areas of the field, maybe that tells us a little bit about the variability of risk within the field. It might be cost prohibitive to variably manage that risk, but that does give us some information about how to use the tool. Some of these other diseases there's potential. So again, late blight or some of these rust diseases, I think that can kind of sweep in and sort of take the field by storm from outside of the field. In those cases, it's probably not as important to the location is probably not as important. It's just important to have it there and be able to get a detection and use that information as part of that decision support system. Yeah. So yeah, the question is, does it work as an early warning system? Yes, but there's an asterisk behind that. It doesn't tell you that disease is going to happen or not, but it's a piece to the puzzle. So certainly it can let you know that you should be scouting, you should be thinking about spraying, that the risk is a little higher, or that it's lower. So yeah. Okay, a couple more questions. Where do you get a Sporenado from? So the company is Sporenado. So yeah, just check out their website. You can get the traps there, and then the cassettes and the tests. We've been running them through 2020 labs. I think most labs should be able to do a DNA test, the PCR test for presence of these, but I'm not sure on that. But we've been working with 2020, so they have a lab I think in Winnipeg and in Nisku. So that's where we've been going through. They've been both these companies have been supporting and working with us on this project. So. Okay, so the question is that the spores could be coming from within or without a plot, and are we trying to differentiate where the spores came from? And this trial it's a field trial, so we're working in farmers' fields. So in that case, it doesn't really matter to us where the spores came from, but if they are present in the field, that's what we want to know to help us understand the risk. So we're not trying to differentiate where they might have come from. And like I said, there are some diseases that tests are being developed or may be developed that have different pathologies that might not be present in the field to begin with, that might sweep in, and that's where a tool like this is really going to give us a heads up that, for rust, it'll give us a 10-day lead on before we start seeing the symptoms, and that's kind of the real value is we're not able to see symptoms of disease for most diseases until it's too late to actually respond to it. So yeah, I mean, I guess that speaks to the early warning system question. It gives us a bit of headway, I guess, a bit of runway to work with. So. Okay, well, if there's no last questions, thanks for all the questions. That was awesome. That kind of kept me rolling. So yeah, if you do have any questions, feel free to give me a shout on Twitter, give me a call, send me an email, I don't know, whatever. And I do try to post updates on Twitter, or we do through the website. So if you're interested in the project, you can kind of follow us. So yeah, lots of information out there. So stay connected.